Chapter 3 summary, which we're going to be talking about the resampling method. So in resampling method, we have several concepts that we're going to be looking at, which they are going to be entailed in this slide. So we're going to get into the introduction to resampling method, then cross-validation, the bootstrap, comparison and practical consideration, and the overall summary, which we're going to be concluding the summary of this chapter. So resampling method, which is a key concept of statistical learning and model evaluation. So in this chapter, we delved too much into the method used to estimate the accuracy of predictive model by applying it to different subset of the data. So this is going to be helping us in understanding how well the model will perform on unseen data. Then when we get to the introduction to resampling method, so we are looking at the training versus test error, of which we see that the test error is more relevant metric for evaluating models performance, and the resampling method help in estimating the test error, especially when there is a limited amount of data. When the data is not enough, the resampling method can help us in estimating that test error. So getting into the second point, which is the cross-validation. So the cross-validation the cross-validation set approach involves splitting the data into a training set and validation set. So in most of the machine learning techniques, what we're doing is to divide our data into two, which is test and training and test, so that we can be able to feed that data to our machine learning and see how well the prediction is going to come out with the unseen data, so we can be able to gauge how well our model is performing. So while we're still on that one, so we can get into the next layer, which is under the cross-validation, which is leave one out cross-validation. So it's a specific form of cross-validation where each observation is there in the data is used as a single validation point, and the model is trained on the remaining data. Like I've mentioned previously on the data split, in order for us to gauge our model. And on this point again, we also learned that this model reduces bias but can have high variance, especially for large data set, as it requires fitting the model in a small data set that is provided. We have another point which is called k-fold cross-validation. So the data is split into k equal parts or folds. The model is trained on k minus 1 folds and tested on the remaining folds. This process is repeated triple k times, which each folds use exactly once as the test set. So that's another validation. So the third point under cross-validation is the bias variance trade-off, which we learned about in chapter 2, where this explains how different sampling method balance bias and variances. And moving on to the third point, where we're talking about bootstrap. So the bootstrap is a powerful sampling technique used to estimate the distribution of a statistic by sampling with replacement from the original data. So the statistics that we are talking about here, we are talking of the likes of mean, variance, and other statistic measurement. So this one, unlike the cross-validation, is used primarily for estimating prediction error. The bootstrap is often used for estimating the accuracy of a parameter estimate. like the standard error of a coefficient in a regression model. So this will be useful in that point. So we also have another point called on under the bootstrap, which is bootstrap procedure. So the bootstrap procedure mostly a live sample of bootstrap sample are generated by randomly sampling from the original data with replacement, like we've mentioned previously, and the statistics of interest compute for each bootstrap and the distribution of the bootstrap statistics provide an estimate of the uncertain around the original statistic. There are several statistics that will be calculated, but this needs to estimate the uncertain around the original statistics that you're going to get from the original data. So last but not least, we have second last point here, which is the comparison and practical consideration. So when to use which method? It's a very good question that a machine learning practitioner might ask themselves. So to use the statistic to check which method is most appropriate, it will for example, cross-validation is preferred when the primary goal is to estimate the test error, while bootstrap is more useful for estimating the distribution of a statistic. So I think this is covering when to use which method, and there are some limitations. For example, the bootstrap may not perform well when the sample size is small or when the data has complex dependencies. So these are the limitations in terms of choosing which method works well in under what scenario. So concluding the chapter, so the chapter emphasizes the importance of the sampling method in modern statistical analysis. This method allows practitioner to make more informed decisions about model selection and to better understand the uncertainty, the prediction, the, the prediction in their prediction. So what we can say we've learned from this chapter is that the cross-validation is essential for estimating the prediction error and selecting models, with k-fold being a practical and widely used approach. So the bootstrap is invaluable for estimating the uncertainty in statistical estimate and constructing confidence interval. Both methods require careful implementation and consideration for the trade-offs between bias, variance, and computational costs, as some will require a lot of energy, and that energy will require a machine to perform very, very well. So in a nutshell, in this chapter, we learned a lot about the mainly gauging our models, the techniques that are going to help us in gauging how our models is doing, and that's it.